lectures. In the previous lecture, in this chapter, number system, we discussed about the properties of rational numbers, definition of rational numbers, irrational numbers, some more theorems about them, and the previous exercises questions. Let us see some more things in this chapter and then we will conclude it. We shall discuss today properties of radicals or surds and properties of exponents. So let us see what are those properties, and then after we will see some exercise questions. So first of all, let us understand the concept of root, right? You have already studied about the square root, cube root, etc. If we generalize it, and if I say that y is equal to x raised to power n, then this same thing we can also write in the manner x is same as y raised to power 1 upon n, right? It is same thing if we understand from example that 2 cube is 8. It is equivalent to write 8 raised to power 1 upon 3 is same as 2, right? And here we say 2 is the cube root of 8, right? Or if I take the example of 4, 2 square is 4, or 4 raised to power half is 2, then here we say 2 is the square root of 4, right? Here in the similar manner we say here x is nth root of y, right? So based on this concept there are some properties, and those properties we are discussing for square roots and applicable to any radical. For example, root a plus root b, root c plus root d. If you have to multiply these two brackets, it goes like root a root c plus root b root c plus root a root d plus root b root d, right? In the usual manner, usual multiplication of brackets, it goes like that. Second property, that root a root c and root b root c, these also can be simplified by using the property that root a root b is same as root ab. Here we are discussing for a and b be two positive integers, right? Of course you can check whether these two properties are valid for negative integers or not. If one of them is positive and one of them is negative, whether they are valid or not, these things I am leaving for you to check, and you will see surprising results. Another property, that root a divided by root b is same as root a upon b, right? One more is there. Of course, your usual square difference theorem, root a plus root b multiplied with root a minus root b, you know, x plus y, x minus y, it is equal to x square minus y square. So by using that, it will be root a whole square means a minus root b whole square means b, right? One more property was written in the textbook. Of course, it is very obvious that if you want to multiply root a plus root b with itself, in other words, if I want to find its whole square, right, just apply a square plus b square formula. A square plus b square is a square plus twice ab plus b square. By using it, it will become root a whole square means a plus root b whole square means b plus twice of root a root b, which means root ab, right? So these are the properties of radicals, and these we are going to apply in our exercise. Now let us see, let's just revise actually, because this you must have learned already. Properties of exponents. Here n is the exponent. So there are some properties, like if I have to simplify a raised to power m into a raised to power n, right? If you observe in the left side, bases are same and the exponents are different. When bases are same, then this is same as you can simply add the exponents. And you know why it happens? It happens because a raised to power m means a into a into a into a, how many times? M times. And this a raised to power n means a into a into a into a n times. Total, if you count a getting multiplied with itself, how many times? First m times, then n times, means total m plus n times, right? So a into a total how many? M plus n times. So a raised to power m plus n. So you can think of its proof also. Now a raised to power m upon a raised to power n is same as a raised to power m minus n, right? With a similar logic you can think of its proof. Another property, when a raised to power m to whole power n is there, right? You can say multiple exponents are there, then these exponents get multiplied with themselves, right? This is. And one more property, that suppose a raised to power m, b raised to power m is there, right? Here what is the difference from this first property? Here exponent is same, but their bases are different. This is nothing but equal to ab multiplied and the whole power m is taken, right? So these are some properties. Now let us see that how to use them in the exercise. In the previous turn we discussed NCERT exercise up to 1.4. Let us see some questions of exercise 1.5. First question is saying that classify the following numbers as rationals or irrational. Some of the numbers are given in this exercise, and we have to examine whether these numbers are rationals or irrationals. So let's see. Okay. Two root 7 upon 7 root 7, 1 upon root 2, and this is 2 pi. Some theorem is there that first theorem, that rational plus irrational is equal to irrational, right? So if 2 is rational and root 3 is irrational, then 2 plus root 3 will become irrational. So with the similar logic, 2 is rational and minus root 5, and the same thing is valid for even for minus also, plus or minus, right? So 2 minus root 5 will be certainly irrational, isn't? And what about the second part? 3 plus 2 root 3 minus 3 plus root 23 minus root 23. So if you simplify, this will get cancelled and this will be equal to 3, which is what? Rational, isn't? Here also you can simplify. 2 root 7 upon root 7 will be same as 2 upon 7, isn't? No square root of primes. This is purely rational number, right? 1 upon root 2. This, even if you simplify, right, it can be simplified. We will see in the next question how to simplify by multiplying root 2 in numerator and in denominator, and then this will become root 2 upon root 2. Root 2 is 2, isn't? So here also one more theorem you can apply. When you take any rational and you multiply any irrational, that will become irrational. Or even this is valid for division also. So here root 2 is irrational and half is rational, and you multiply them together, then this will become irrational. So this is here irrational. Right. 2 pi. Pi is an irrational number. 2 is rational. So rational into irrational will become irrational. So this is irrational. Right. Another theorem is that when you take two irrationals and then you plus or minus or divide or multiply, whatever, and this work you do with irrational, this may be rational or may be irrational. Right. For example, root 2 into root 3 is what? Is root 6. Irrational into irrational is irrational here. Here what happens? Irrational into irrational is equal to irrational. Isn't this one example? Another example, that root 2 into root 2 is 2. So here what happens? Here irrational into irrational equals to what? Equals to rational. What I am saying that when irrationals and irrationals are operated together with some operation, either addition or subtraction or multiplication or division, the result may be rational also, the result may be irrational also. Right? It depends case by case. Let us see some more questions. Not all parts of second question, only some part. Let us see part 4. They are asking us root 5 minus root 2. What happens when it multiplies with root 5 plus root 2? Right, a minus b into a plus b. If I apply it is a minus b. It's simple. Nothing special in this, isn't? Another part, first part, second part, third part also are based on the properties. Recall, pi is defined as the ratio of circumference of a circle to its diameter, say d, c upon d. They are asking that pi is the ratio of circumference and diameter. Then this seems to contradict the fact that pi is irrational. How will you resolve this contradiction? See, pi is what? Pi is the approximation of this c upon d, right? Because exactly in a circle, if you measure c, circumference and diameter, and divide, right, measurement will be up to some decimal places only, right? Circumference, if you measure, you are not going to take in non-terminating or non-recurring kind of thing. It will somewhere terminate only. So when you take such rational number in numerator and denominator and divide, the final outcome will be a rational number. But they are saying pi is a rational number. Then how it can be a rational number may be equal to a rational number? So what is the solution for it? What is the answer for it? That is the question. The answer is that pi is approximation of c upon d, right? So that's why one is irrational, the other is irrational, but they are actually approximate value of each other. Another one is fourth question. They are asking root 9.3 to be represented on number line. Root 9.3, we have seen this concept, that how to do it. Let us see once more. To draw root x on number line, the way is that what you do, you draw a number line. Let us suppose origin. Right. Let us directly discuss root 9.3. Root 9.3. Take 1 unit on this side and 9.3 unit on the left side. Say this point is A, this is O, this is B, suppose. Now you assume AB as diameter and draw a circle. Isn't? No, how to draw? You can find out the midpoint and you can find out the center and then you can draw a semicircle. Right. Now at O, draw a perpendicular. Right, draw a perpendicular. Right, and now where the perpendicular meets this point and origin, if you try and say this point is P, this will be root 9.3, isn't it? This is the way that we discussed. Now root 9.3, you can fill in the arc and you can mark one arc here, and this distance is going to be root of 9.3. Right, the proof already we discussed in previous videos. Please see that video if you have not seen, and proof also will you'll understand. Now let us see about the next question. Next question is about rationalize the denominators. Now, to rationalize the denominator, we have a way. Let us see. From question also, only let us discuss. The first one is that 1 upon root 7. See, if the denominator, the down part, if it is purely an irrational number, simply you multiply with that same irrational number in numerator and denominator, right? So if I have to solve it, I can multiply with root 7 in numerator and denominator, right? And then give a simplification. This becomes root 7 upon 7. This is now this has become a rational number, right? Now, if I want to simplify one more, second part, 1 upon root 7 minus root 6. Now, root 7 is irrational, root 6 is irrational, their difference is also irrational, right? Because after simplification it won't come a rational number. Now, here if you want to rationalize the denominator, the way is that what you do, you multiply numerator as well as denominator with what? With conjugate of denominator, right? So if I multiply with root 7 plus root 6 in numerator and in denominator, right? How this has come? You take exact number and make the sign opposite of any one term, right? That becomes the conjugate here. Root 7 minus root 6 you take, and root 6 sign you make opposite. So you get root 7 plus root 6. That is called as the conjugate, right? So that you multiply up and down. And if you multiply this into 1 goes root 7 plus root 6, right? Whole divided by a minus b into a plus b is a square minus b square, root 7 whole square minus root 6 whole square, that becomes 7 minus 6. And 7 minus 6 is nothing but 1, and this gives you root 7 plus root 6. And the denominator is here, this 1 rationalized, right? One more can be taken, fourth part, root 7 minus 2. One upon root 7 minus 2. Right. Root 7 plus 2 also you can multiply up and down, or minus root 7 minus 2. I just want to keep the things positive, so root 7 plus 2 I am going to take, and I'll multiply in numerator as well as in denominator. Right. Finally it is going to be the same thing. Root 7 plus 2 into 1 becomes root 7 plus 2 whole upon a minus b, a plus b becomes 7 minus 2 square, right? And this will be 2 plus root 7 whole divided by 7 minus 4, which is nothing but 3, isn't it? And here the denominator has become a rational number. So this is. Let us see 1.6 exercise of NCERT book, which is based on the properties of exponents. Let us see. Some of you may find these questions very easy, so I would suggest that find some more problems from NCERT exemplar, from AES worksheets, modules, and try to solve them. But let us see 1.6, some questions only. They are asking find the following. And all properties we have discussed. Let's apply 164 raised to power half, 32 raised to power 1 by 5, and 125 raised to power 1 by 3. These are all things we have to simplify. See, you have to keep remember, some things help you a lot, like 2 all powers, at least up to 10 if you try to remember, right? It will help you to do the things directly. Those who have studied computer science, they must have seen these things while discussing binary system, right? Leave it. 64 is nothing but 8 square, right? You know, when there are multiple exponents, they get multiplied. So a raised to power 2 to whole power half becomes 2 into half, 8, isn't it? 32 is nothing but 2 raised to power 5. So 2 raised to power 5, 2 raised to whole power 1 by 5, it becomes twice 2, right? 5 into 1 by 5 becomes 1. Now this one, 5, right? 5 into 5, 25 into 5 becomes 125. So 5 cube it is. 5 cube with 1 upon 3 power, if you simplify, it becomes 5. Simple. Second question, let us see. Let's see what is different here. The first one is 9 and the exponent is 3 by 2. Second part, 32 and the exponent is 2 by 5. And the next one is, okay, the next one is 16 to power 3 by 4, and the last is 125 to power minus 1 upon 3. Okay. 9, 32, 16, 125. Let us factorize them and let us write as power of something. 9 can be seen as 3 square, isn't it? Then it will become 3 to power 2 into 3 by 2, isn't it? 2 get cancelled, and finally it will be 3 cube. 3 cube is 27. This is 32 should be seen as 2 to power 5 to whole power 2 by 5. 5 into 2 by 5, 5 get cancelled, 2 square, which means 4. 16 is what? 2 to power 4, isn't it? 2 to power 4 with multiplied with 3 by 4, it becomes 2 cube. 2 cube is nothing but 8, right? 125 is 5 cube to power minus 1 upon 3. 3 gets cancelled and it becomes 5 to power minus 1, which means 1 upon 5, right? This is. So these all the questions are there. One more, let us see. Third one. People who find it easy and people who got the concept, will find it super easy, right? Third question of the same exercise, let us see. Let's simplify. What to simplify? 2 raised to power 2 by 3 multiplied with 2 raised to power 1 by 5. Right. We've seen one property that a raised to power m into b raised to power m is same as a into b whole power m. Right. So here I can see this base is same, 2 and 2. So it will become 2, no, not this property. Here I am going to use this property. A raised to power m into a raised to power n becomes a to the power m plus n. So if base is same, so power will get added 2 by 3 plus 1 by 5, right? It's not difficult to simplify. 10 plus 3, 13 upon 15, right? This is, I don't think it can be simplified further. One more question. 1 upon 3 cube whole power 7. You can think what should be its solution. Another is 11 to power half upon 11 to power 1 by 4. That also you can think. And fourth one is 7 to power half into 8 to power half. Right. Multiple exponents. Exponents get multiplied. Right, 7 into 3, it will become 3 to power 21. 1 upon 3 to power 21. Which property? A to power m upon a to power n is equal to a to power m minus n. Powers get subtracted finally. Right, so half minus 1 by 4. So how much it will become? Half minus 1 by 4? 1 by 4. This is, right, and I don't think it can be simplified further. So leave it as it is. Now here, when exponents are same, bases are different, then what happens? This becomes 7 into 8 and the power becomes half. Right, 56 to power half. Right, if you want you can split it further. 8 you can, I can write it 14 into 4. 4 to power half can be taken out. It can be written as 2 root 14. Right, this can be done, no problem. So this is how we have to do this kind of questions. Now there are some more questions which are given in NCERT exemplar. Somebody has asked me one question, that how to represent 8.7 on number line. This question is quite same as the question. One question was to represent 8.7 on what? On number line. Somebody has asked during the live chat. 8.7 is quite same, just like your 9.3. It is without root. So directly 8.7. 8.7 is quite simple. It is 0, 1 and 8, 9. Then between 8 and 9, just divide the place into 10 equal parts, right? And then just select. This will become 8.7. Right, up to 1 decimal place it is not at all difficult. Right. Some questions. Rationalizing one, let us take. And then with these supplementary problems, we'll conclude this session. Question is about simplify four upon 3 root 3 minus 2 root 2 plus 3 upon 3 root 3 plus 2 root 2. Right. It may have two ways of simplifying. That first you simplify the first term. How to simplify? By rationalizing the denominator. Right. How to rationalize the denominator? By multiplying up and down with 3 root 3 plus 2 root 2. Right. It will become rationalized. Simple. Then similarly the second term you can simplify by multiplying 3 root 3 minus 2 root 2 up and down. And then those two terms you can add or subtract and simplify. That is, Another way is directly you can take LCM. If I see these two, if I take LCM, they will become a simple quantity. So I'm going to do by second method. I'm just going to take the LCM, right? It will become 3 root 3 minus 2 root 2. I'm writing fully 3 root 3 plus 2 root 2. And if you multiply, it will become 4 3s are 12, 12 root 3 plus 8 root 2 plus 3 3s are 9 root 3 minus 6 root 2, isn't it? And if you simplify like terms together, root 3, 12 plus 9, 21 root 3, 8 minus 6, right? 2 plus 2 root 2 whole divided by a minus b into a plus b becomes a square minus b square. So this is going to be 3 root 3 whole square minus 2 root 2 whole square, and this will become 21 root 3 plus 2 root 2 whole divided by 3 3s are 9 into 3, 27 minus 2 2s are 4 2s are 8, and this will become 21 root 3 plus 2 root 2 whole divided by 19, isn't it? And the denominator has become rationalized, and this is simple, right? Like this. Some more question, let us see. One question is there. One question is that suppose x is root 3 plus root 2 upon root 3 minus root 2, and let y is root 3 minus root 2 upon root 3 plus root 2, then find x square plus y square, then x square plus y square. So let us see how to simplify. क्या कहते हैं आप लोग? डिनोमिनेटर को रेशनलाइज किया जाए, isn't? और x and y में कोई रिलेशन है. Actually x is 1 upon y. X is 1 upon y. Whatever. X equals to root 3 plus root 2 upon root 3 minus root 2. If I simplify by multiplying root 3 plus root 2 up and down, this is going to be root 3 plus root 2 whole square, means 3 plus 2 plus 2 root 3 root 2 root 6 divided by 3 minus 2, which means 1. This will be 3 plus 2 5 plus 2 root 6 divided by 1, nothing. This is x. And similarly y, also similarly can be simplified. If I take y, which is root 3 minus root 2 upon root 3 plus root 2, and if I multiply the numerator and denominator with the conjugate of denominator, this is going to be, denominator will become root 3 minus root 2. Root 3 square minus root 2 square means 3 minus 2 means 1. Numerator will become root 3 minus root 2 whole square, which means 3 plus 2 minus 2 root 6, isn't it? Nothing but 5 minus 2 root 6. What I have to find? I have to find x square plus y square. Squaring we have to do, no problem, we can expand the whole square. This is 5 plus 2 root 6 whole square plus 5 minus 2 root 6 whole square, right? This can be, I think, twice of 5 square plus 2 root 6 whole square. It will become, no problem, I am expanding completely. 5 square plus 2 2s are 4 into 6 24 plus twice into 5 into 2 root 6 plus 5 square plus 24 minus 2 into 5 into 2 root 6. This term will get cancelled, right? 34, 68, finally it should be. Isn't it? This is. Now somebody is asking that root 8.7 how to show a number line. Root 8.7 to show on number line. Okay, so similar the way that we have seen, this is origin 8.7, you measure and mark one point, say it is A. Here you mark 1, say it is B. Right, now you take total AB, right? Find the midpoint. How? By drawing a bisector of it. Find the midpoint, right? And now you take this point and this distance as the radius and draw a semicircle. Right. Now from origin draw a perpendicular. You know how to draw. You can draw a perpendicular. And where this perpendicular meets this semicircle, say this point is P. Right. Then as per the rule, as per the theorem, this distance OP will be nothing but root of 8.7. Right. And then this OP distance you can fill in your compass and you can keep the needle at O and mark one arc. Suppose the arc cuts here. Right. Say this point is C. Then this OC distance will be nothing but root 8.7. Right. Already this is a number line. Right. So this is the way how we can show root 8.7 on the number line. So these are the questions of our NCERT exercise mostly, and some more questions. That's all for this lecture today. I request you that do not stop here. Right, the full confidence and the real joy of doing these questions of number system you will get when you solve more and more questions. I request you to please see AECS modules which are already shared with you, and please see NCERT exemplar book and some more reference books, and please try to solve some more questions. Keep sending your doubts, confusions to me. I'll surely take them in our next lecture. Thank you so much.